we look at the regular octagon in example A, one way we could find out a value for the area is to do 2 multiplied by a side length squared all over tan 22.5 degrees. But before working out the area of this octagon, we can look at the regular octagon we have here on the right and use it to show why we can do this sum to work out the whole area. Now it turns out that a regular octagon can be split into 8 smaller identical isosceles triangles. Now at this point we can work out the size of the inner angle of each triangle. If we recall that for a full circle there are 360 degrees. As we have 8 identical triangles, division by 8 will give us the size of each angle here, and this turns out to equal 45 degrees. So each triangle is the same size, which means each side length also is the same size, and we can look further at specifically one of these triangles. The base of each triangle is a side length, and the height is the octagon apothem, which would be a straight line from the centre to the middle of one of the sides. But we can go a bit further here and split one of these triangles in half. And this is the result. This angle now becomes 22.5 degrees. The height remains, but the base is a side length over 2. Now, why we're going down this route, if we recall the area of a triangle, so one of our 8 smaller ones, that can be given as standard by half multiplied by the base multiplied by the height. And as 8 of these triangles make up the area of a regular octagon, octagon area would be half multiplied by the base, which is a side length, multiplied by the height, which is A, multiplied by 8. So what we want to do is obtain an expression for A. Now, as this is a right angle triangle, if we remember the tan ratio, it's for an angle is the opposite side over the adjacent side. So for 22.5 this is S over 2 over A. So using this we can write tan 22.5 degrees. At this point it's S over 2 over A. Now it doesn't change the overall value of everything. If we multiply top and bottom by 2 on the right side, which changes things slightly, the appearance that is, we will have S over 2A, and if we write 1 on the left side over tan 22.5 degrees, this flips around the right side, so we now have 2A over S here. Now we can multiply both sides by S over 2, and on the left it will give us S over 2 tan 22.5 degrees. But on the right, 2 will be cancelled by 2 below, and the s below will be cancelled by the s above, and it leaves us, which is what we're looking for, with just a. So now we can proceed over here as we try to find an expression for the area of the whole regular octagon. So for a we have s over 2 tan 22.5 degrees, of course multiplication by 8, and if we do multiply all this out, we have 8s squared on the top line, 4 tan 22.5 degrees, which can be simplified further to just 2 s squared all over tan 22.5 degrees, which is what we were doing for example A. So this is why we can do this sum. As long as we know the side length, that is all we need to proceed to try and work out the area of a regular octagon. And if we proceed, example A, multiplying out the top line will give 242, bottom line staying as is, and for the area we get 584.24 meters squared. That's rounded to 2 decimal places, and that is how we can work out the area of a regular octagon, provided we do know what the side lengths are.